In this week's screencast, we'll be introducing Factory Boy. As you remember last week, we used this initial data file that allows us to populate the database with some test data beforehand. This can be often troublesome to deal with. Today we'll be introducing a tool that will by far simplify this process. I'm going to go through and write the factories for each one of these particular models that we contain in our current application, and then we're going to rewrite our tests from last week to use Factory Boy. So here's the documentation for Factory Boy. Factory base is based on Thoughtbot's Factory Girl, which is the same thing for Ruby on Rails developers. It includes a straightforward syntax. It's quite simple. All that stuff you can read on your own. That's how you install it. And let's just go through an example here that they have in the documentation. All this simply does is imports factory, imports the models that we'll be using, and then from those models we instantiate factory classes that generate or tell us how to generate new models for our classes. So for example, if I wanted to create on the fly user object, what I would do is call user factory bracket, that would instantiate a class, and then you can either do build or save. That'll generate a new class, a new model of that instance saved to the database, which you can use to test against. It's fairly straightforward. The model, I'm sure, only has a first name, last name, and an admin. Everything else is just left alone. This is probably best illustrated through a legit example. So let's quickly open up our factories file. Please note the name. This file is called factories, not factory. If you were to do that, when you go to import factory, you'll get a bunch of errors. This tricks me up every time I create a new factory file, but please watch out for that issue. So we're going to import some of the models from the game module. So we're going to import models here. That simply has a game module here. That's all that has. So it's fairly straightforward. And we're going to also import some of the things from the register module, which is a sport and a player. So from register modules import player and sport. Seeing as sport's the easiest one, let's quickly write a factory for that. So class sport factory dot Django model factory. Factory Boy has a couple of backends that it supplies. That is just the one for Django. So you need to, at the very beginning, you need to go factory_for, which declares which factory this particular thing is attached to. So we're saying that this is a factory for the sports models. As you can see here, the sports models, all it takes is a character field with 30, which is the name of the sport. Very simple. So we're going to go sport is equal to factory iterator, because there's only so many sports in our sports. Our app only supports 5 sports, which is soccer, basketball, volleyball, hockey, and baseball, and they don't repeat. So you can only create 5 of those things. Once you go past that, if you try to create more instances than that, it'll throw an error. So let's quickly pass in our models here, our string characters here for our field here. It's going to be basketball, volleyball, hockey, and baseball. We don't want these to cycle, so if this was cycle, defaults to true. So if we create more and more instances beyond the 5 that we have here, it'll keep creating them, which we don't want, since our application only supports 5 sports. We're going to create our user factory, which the player class depends on. So we're going to go user factory. I'm going to copy this over from here. I'm going to be factory for user. We then need to import user, which comes from contrib Django. So from Django contrib auth models import user. Great. And for that, simply basically all we need is username is equal to factory dot sequence. This allows us to generate a sequence of usernames that are independent, that are all unique. So what that simply does, it's a lambda function that has n as a variable, and then we just go username pass in a directive, so that'll be a 0 here, and that'll format that with n. So format with n, and that's that. So each time it generates a new user, we'll have user 0, user 1, user 2, user 3, user 4, and then we're going from there. Same goes for first name. Let's pick a cool first name. We're gonna call it Madi. It's a pretty cool first name. And same goes for last name. Yusuf. And email. Pretty straightforward. Just needs to follow the structure of an email, which is madiblah @gmail.com. And that's great. And then you have your user factory. Now it's going to get tricky. Next one we want to do is a player factory, which relies on a user factory. So if we go to our register page, you'll see that the player model has a foreign key to the user model. Now you may be thinking, okay, first create our user, then create our player model. You can do that, or you can have something called a post generating sequence that allows us to have a subfactory. So for example, create the same factory as we did before. Factory for player. Then we have a user, which is the same foreign key that we had before, but we call this a subfactory. So we simply say, for this model here, you call the user factory. So each time a player is created, we also create a user factory. Very simple, very easy. Let's take another look at our models again. We have gender and we have sports. Sports is a many-to-many field, which could pose an issue, and our gender field is just a character field. Now you may be thinking, how do we have an alternating character gender set? It's very easy. You can use the sequence decorator provided in the class here. So all we need to do is go add factory dot sequence. This time this is a decorator. We can pass a function. The function needs to be named after the field that it's representing. So in this case, we're creating the the gender field. Now if n modulus 2 is equal to 0, return a female character. Else, return a male. And that is that. And then we have, so for alternating players created, one will be female, one will be male, one will be few, one will be female. Quite simple. Next, we want to be able to create multiple sports attached to our field. So we saw here that we had a many-to-many field to the sport class. So what we do here in our factory is actually quite simple. It's called post generation field, and all that says is diff sports. So we take our field name, we have a self, we have a create attribute, we have the extracted variables, and then we have other keyword arguments that are passed down to the function here. If not create, so if it's not a create call, meaning that we're not trying to create an actual instance of this thing, we return, we move on. If we aren't, then we go for sport in extracted, extracted being the list of sports you passed in. Self sports dot add sport, and that simply adds the sport that we passed in the extracted method to this particular player, and that is that. So seeing as we have those three things, we've talked about many-to-many fields, we've talked about sequences with alternating behavior, we've created sequences where it allows you to generate unique names and emails, and then we have a pretty generic structure for having to deal with models and creating models. So this takes a little bit of effort up front to get all done, but once it's all done, it works quite nice. Next, I'm going to show you how to create your tests and use the factories in your tests for increased speed and decreased test independence. I've gone ahead and taken the liberty of writing out the game factory class. The only few things you need to keep an eye out for that are new here are factory hidden args, which tells us that this particular field here does not exist in the actual model. As you can see here in the game model, there's no column called now, so it just removes that. The only reason this exists here is so that we can instantiate our start date time with a time that is in the future. So what this allows us to do is generate a date time that is today based on today's time, and then we say our start time for the particular game here of interest is 4 days after that particular time. Lazy attribute allows you to create attributes that are dependent on something real time. So in this particular case here, it's dependent on the UTC now whenever the object is created, and this allows us to evaluate 4 days ahead of this time. So to take consume a little bit more easier example, let's quickly go back to our user factory. If we wanted our user factory email to be based on the first and last name, we would make the email a lazy attribute, and then that lazy attribute would have two things that would take in, the first and last name, and then our emails would be first.lastname@gmail.com. That's what lazy attributes are used. They're allowed for you, they're used so that you can evaluate things on the fly as you go, dependent on other fields in our object. We've also added a latitude, longitude. These are just sequences. They'll be in or around the auto area. We've created a static variable for that one. We also created a sequence for active. We may in the future want to have inactive. That's why we made this a sequence. And we have another post generation field, which is for the players. Multiple players can be part of the same game. As you can see here, it's a many-to-many field with the players. You create the players, you pass them in, they get assigned to the game. Awesome. So let's go back to our test file and let's rewrite it to use FactorBoy as opposed to importing and loading our initial JSON dataset. Before we do that, it might be interesting just to see what happens when we recreate our database and run our tests from scratch. So let's just quickly do that real fast. As you remember from last week, running our test is as simple as running PyTest. As you can see that the test for assertion that the page loads 200 comes back without issue, but the test for checking to see if there's one basketball game in the front page fails. So let's run this without let's reverse the F. Okay. Let's run this again. So what we need to do now is to simply create and set up our models to reflect what we want to test. So that's just simply going through the process of creating all the factories. So what we're going to do is we're going to import our factories. So from factories, import the player factory, sport factory, and our most recently created game factory. Each of these can have setup methods. In this particular case, that fits well because we need to create all the sports here. So we're going to go self.soccer is equal to sports factory Factory Boy has 2 steps for creating an actual model. If you call it like we did here, it will build and create the model. If you want to just build it, you'd simply call build, and that would create an instance of that object, not a thing actually saved to the database. But if you call it like this, it'll save it to the database. So we're just going to continue and create the rest of our variables here. Remember, this is inside an iterator sequence or iterator factory, which means it'll keep creating them until it exhausts the sequence that we passed in, and we're declaring our sports factory, and then any declarations past that will cause an exception. So that is the reason why we're able to create these without having to specify which actual sport they're associated to, since I know the order in which I typed them into there. Now we also want a couple of players. This goes ahead and creates a user as well, since a user is the subfactory of player. So then we can simply go ahead and check to see in our second model. I want to create a third player, which is specific to this test. We want to call create, which is what I was alluding to earlier. This create method allows us to specify sports. So for example, each player has a group of sports they're associated with. That was our first post generation portion that we wrote. Seeing as our sports were above, this takes a tuple which gets assigned to the extracted field as we wrote earlier. So if we go back to our player factory, the list of sports is in our extracted field. The reason we're calling create is so that it knows that we are creating a sequence of sports that are going to be attached to this particular player. Extracted is a tuple, takes a tuple. You can iterate over tuples like you can lists. That's just the syntax they happen to choose with Factory Boy. We're going to say that this particular player is a soccer player and a basketball player. Once we have that, we've created a player of that type. We want to get the user for that player so we can create a game. So player.user will give us the user of this particular game, and then we're going to go game is equal to game factory owner is a user. Now we could simply just go and let the subfactory handle this, but the reason we're passing it in is so that we can make assertions on it on that particular user later. So we'll need a reference to keep around. We're going to also go players is equal to, again, there's a post generation portion of this. The players of this particular game include the players we created in our setup function, so player 1, player 2, and the particular sport we're interested in creating today is a basketball game. So once we go ahead and create that, we should invalid syntax somewhere here. Missing the closing bracket here. One too many here. So we have all that done. We open the game. We should have an assertion now. Once we're all done, this will create a player. We'll get the user for that particular player. We'll create a game factory, and then when we assert and load our page, we should have one basketball game in context. So let's go ahead and run our tests again. There's no module named factories. The issue there was that the factories file was saved to the wrong module. I've since moved it over. Should be okay to run our tests now. We run our tests. Boom, we get a stop iteration. That's interesting. So what I outlined at the beginning was saying that the stop factory here will keep generating them. Each time we call, we'll generate the new module, and it will not iterate. So once it hits the end of this and we try to create a new one, we'll get a stop iteration error happening. So if you know anything about setting up tests, you'll notice that this file here, The def setup is run before every test. So it'll run it once before this test and then once before this test. And that'll obviously get us over into the 6th sports object, which will then cause the stop iteration to happen. As you can see, most of our stuff here is isolated inside. Most of our logic for needing models is isolated inside our test home view. So let's move that down into that. Let's get rid of the setup. Generally, you should try to avoid setup things unless you need to have them there, just to slow down your tests. Try to keep everything isolated. Try to keep everything that you're testing to be inside the function in which you test what you're trying to test. So if you need to set up stuff for your test, try to write it in that function as we're doing here. So as you can see, we moved everything up. Also, there's no need now for this superfluous self here. So we're going to go ahead and grab all those selves, delete them. You can do the same thing here. And save that. So, so as you can see, everything's isolated inside our test home view. So all our tests are here. Everything that we needed to create for our test is here. Awesome. We could probably even make this a bit simpler and just do that. Get rid of that extra variable declaration. Awesome. Now let's go ahead and run our tests. We went ahead and saved. Let's run our tests again. There is no none type in this object iterable. So the problem here was that we had an else rather than if extracted. So if extracted is provided, then run this, as we have here. It would always run it even though there's nothing provided. So if we run our test now, everything passes. We are at the same functionality as we were last time, but this time we're using Factory Boy. We can then create our tests a lot quicker in the future. We also have our isolated tests. So everything's isolated to this test. So if anything breaks in the future, all we would have to do is remodify how we're creating things and make our assertions. This will increase your test speed in the future. It'll decrease complexity when dealing with test data. It'll also allow you to have much more confidence in your tests because you know exactly what broke and how to reproduce it.